Good afternoon, Math 20-1 students. Welcome to our Week 8 tutorial. We are almost there. Let's see, Section 1, Quadratic Functions. Oh, sorry, this is the wrong title. This is, we're talking about rational expressions. We're trying to solve rational equations. And what we really mean by rational expressions is just fractions that have variables in it. And so don't be afraid of rational expressions. If you're comfortable with fractions, you can also do the same thing with the variables as well. So let's take a look at the first question here. So we have the first question. We have we have two rational terms here, and we can take a look. We can almost think of them as fractions. So you can think of just these as fractions with x instead of talking about the technical term of rational expression. And I might switch back and forth, but let's take a look at this. We need a common denominator when we are adding fractions. Now, common denominator means we have both this factor in it and this factor in it. Now, what we're going to need then is we're going to need something like this. So we have something that has a 3 in it, and we also need something that has an x in it. So let's take a look then. We have something like this. In order for this x then, this is already x, so that's the 3. We added the x part to this fraction. So we're going to have to add another x. So take a look at this part here is what we added, but notice that what it originally was x over 3. So if we add that to, we have 3 over x. And this time I'm going to use a different color here and say, well, that's going to need a 3 to make it so that there's common denominator of 3x. And we also do it on the top. So really what we're doing is cleverly multiplying by the number 1 so that we don't actually change each of these terms. So this thing, x times x over x, 3 times x, is the same thing as x over 3. And this 3 over x is right there. And it's just cleverly multiplied by 1, right? Multiplying by 3 and dividing by 3, and then this equals 2. So once we have this, then what we can do is once things are in a common denominator, we can just really numerate the numerators. So we have this x times x, which is x squared. And then this is 3 times 3, which is 9. So we have x squared plus 9 over 3x, that's equal to 2. And now we can think, well, what can we do now? What we can do is actually we can solve, well, we should notice that that x here is not allowed to equal 0 because we can't divide by 0. That's a rule in mathematics we shouldn't break because then things go wonky. We don't, we get some really strange answers and answers that don't make sense. So what we can do here is since now x is not allowed to be 0, that means that we can multiply then both sides by x. So let's see, let's multiply by, well, let's multiply by 3x actually. So we'll multiply this by 3x, multiply that by 3x. We get x squared plus 9, those will cancel. And then we have 2 times 3x, which is going to be 6x. Well, this is getting closer to something we can solve. This now looks like the quadratic equations that we are so familiar with. We have x squared minus 6x plus 9 equals 0. Of course, one of the strategies is to set this to equal 0 so that we can solve for it. And now we can factor this. I'm going to leave the factoring to you, but notice that because the coefficient here is 1, that you're looking for x and x in front here, and then whatever this is going to multiply to become this x squared minus 6x plus 9. You're going to solve each of these brackets to equal 0, and then each of those x's will be your answer. Of course, making sure that you can repeat here that the restrictions are x is not allowed to equal 0. Okay, let's take a look at the second question here. We're going to try and solve, now this looks like a very intimidating question, but we can still tackle it. So let's take a look at what we have here. We have x minus 24 over x squared minus 8x, and this is this looks pretty daunting. But what we can do is we take it a piece at a time here and say, well, what if we factored the bottom? So if we factor the bottom, we would have our x times x minus 8. Well, that seems reasonable. We have our x minus 24. And then here, that means that we want all of our rational terms to have this x times x minus 8. So here we have 5 minus x, and that has, oops, that has x minus 8 already. So what we need then is we need to have this one also have an x on the bottom here. So then it would become the x squared minus 8x. So how do we do that? It would be x times x minus 8. And so notice we're not changing the value of this term. But what we're doing is we're cleverly multiplying by 1 so that it has a common denominator. In the same way that, you know, if 3/4 isn't useful to us, but 6/8 is useful to us, what we've done really is we multiplied the top and the bottom by 2 to get the fraction with the right denominator that we need. Okay, so then this equals, we have 2x plus 3 on the top here, and then on the bottom it has x. So let's see what we can do here. If we rewrite then this, it has an x already, and what we can say then is it also needs an x minus 8 so that it has the same denominator as everything else. So I put the x minus 8 on the bottom, and of course I'm cleverly multiplying by 1 here. So that you have an x minus 8 on the bottom, you have an x minus 8 on the top. So let's see if this can simplify. So everything is on top of x times x minus 8. So then we can say we're multiplying by x times x minus 8. And why can we do that? Well, we'll say x is not allowed to equal 0 because that would make the bottom 0. And x is also not allowed to equal the number 8. So then we'll see what happens there. See, if x was equal to 8, 8 minus 8 would be 0, and then we would be dividing by 0 in this case, or this one, and eventually this one as well. But let's take a look here. So we have x minus 24. Now we can multiply things through. So this is minus, we have a 5x minus x squared. And then this is equal to, let's see, we're going to multiply these two binomials together. So 2x times x is 2x squared. 2x times negative 8 is negative 16x. And then we have plus 3x, and also plus 3 times a negative 8 is negative 24. Now all of this is over x times x minus 8, but we can, since they're all the same, we can multiply the whole equation by x times x minus 8, and all of the denominators will disappear because it's the same, right? So we're multiplying everything by x times x minus 8. So that will cancel out, and this will cancel out, and this will cancel out. You can't do that right away here because you have different denominators. You can only do it if it's the same. So let's see if we can simplify more. We have x minus 24. We have this is minus 5x, and minus a negative x squared is going to be positive x squared. We have this is equal to 2x squared minus 16x and positive 3x, that's minus 13x, and then minus 24. I think we can see that there's a minus 24 on both sides, so we'll just cancel out those. Let's see if we can collect a little bit more here. We have an x squared here, so that's going to take out one of these on this side. And so we have negative 4x here, because we have 1x and negative 5x, is going to be equal to x squared minus 13x. So if we try to set everything equal to 0, we'll make this side equal to 0 because the x squared is on this side as a positive. So we're going to add 4x to both sides because negative 4x plus 4x will become 0. So we have 0 is equal to x squared minus 9x. I'll leave this to you to solve here. If you can factor this and then solve each one, then you can determine what the solutions are. Be careful though, because one of the solutions may be one of the restrictions. Remember, if you find a solution that is one of the restrictions, then you cannot use it. It's not allowed. So, and you know, in some cases you might not find any solutions, but in this case, I think you will find one. Okay, so let's take a look at our next example. We have our, we need to solve this equation. Again, it looks a little daunting because we have a rational term here, we have just an integer, and then we have another rational term on the other side. So taking it one step at a time, if we can make everything have the same common denominator, then we can use that trick of multiplying by the common denominator, and then it becomes an equation that doesn't have a rational term in it. And therefore, we can use quadratic solving skills to solve the equation. So take a look here. We have x minus 4 seems like it's a good choice for a common denominator. So we already have 5x over x minus 4, so we don't have to change anything. It already has the correct denominator. We're going to have to multiply this 2. We wanted to have an x minus 4 on the bottom, but to keep the value of 2, we're going to put the x minus 4 on the top as well. Again, this is a clever way of multiplying by 1, right? Take the number 2, multiply it by something over the same thing. So really it's just multiplying by 1, but now it becomes a term with the denominator that we want. So let's take a look at the next piece. We have 3x plus 8, and that's over x minus 4. Now this is cool because each of these denominators now have the correct denominator, so we can multiply the whole thing, the whole equation, by x minus 4. So if we take the whole equation times x minus 4, see what happens. It's going to cancel out this piece, it's going to cancel out that piece, and it's going to cancel out this piece. So what we're left with is just 5x plus 2 times x minus 4 is equal to 3x plus 8. All right, if we continue this, and now remember, the reason why we can multiply by that is we've said earlier, x minus 4 as a restriction cannot equal 0. So that means that x is not allowed to equal 4. Okay, if that's the case, then we're allowed to multiply and cancel everything out. So when we have this, we have 5x plus 2x minus 8 is equal to 3x plus 8. And we have, so this means that we can subtract here. This is 7x. So let's just keep this as 7x minus 8 is equal to 3x plus 8. And so set minus 3x minus 3x. These are solving equation skills that you're most confident in, hopefully. We have 4x minus 8 is equal to plus 8. And we have then 4x is equal to 16. Now, when you continue to solve this, you're going to get a value at x equals something. And then we will check it against any of the restrictions that we have. We may even choose to put in the value back into the equation to make sure that the left side equals the right side. Now, you'll find that in some rare cases that you might have equations where there is no answer at all, because even the answer you found doesn't seem to work. Will this be the case in question number 3? Well, I'll leave that for you to figure out. But remember that one of the things that you need to watch for is once you have your solutions, you need to check them against the restrictions, and you may even choose to plug them back into the equation to verify that the left side equals the right side. Because in some cases, you might get both answers, you might get one answer, or you might not get any answers at all. All right, so here, question number 4, these word problems are tough, and it takes a little bit of work to work on them. Let's see what we can do here. So we have our Callie and Meg, they go on a 3-hour bike ride, and they ride with 15 kilometers with the wind at their backs, and then when they come back, it's straight into the wind. Not very fun. Let's just determine their average speed of the bike ride when we don't talk about wind. So the wind's not helping them in one case, and it's not going against them in another. I think what will be important here is if we can use our organizational skills to see if we can separate some ideas here. So here, we'll say that if we connect, make this kind of table here, and we can say, oh, all right, let's do the, we'll say this is a distance, so distance. And we also have a speed, and we have a time. With a lot of these rational equations and a lot of problems in general, setting up a table might be very, very helpful. So let's say we go on a bike, right? So this is the go, and then there's like a go trip and a back trip. So this is going somewhere and then riding on the way back. So where do they go? They went 15 kilometers. So this is the distance in kilometers. So they went 15 kilometers. They also means that they went 15 kilometers back as well. But what was their speed? Well, we say that there's a speed that they go, we'll say that it's x, but when they're going towards some place, the wind is at their backs. So the wind is actually helping them with a 3 km/h speed. So it's actually pushing them at 3 km/h. So their speed is their normal speed if they didn't have any wind, and then the wind is helping them by going 3 km/h faster. So we can say that the speed is x plus 3. Now what about on the way back? The wind is going against them. So they would normally have a normal speed like x, but when the wind is going against them, it actually slows them down by that same 3 km/h. Now, where does the rest of this equation come from? The rest of this equation comes from the fact that time is equal to distance over speed. So you've seen that speed is equal to distance over time, and that distance is equal to speed times the time that you went. And here is this relationship, and in the table you can kind of see it, is that here if the time is equal to distance divided by speed, then the expression for time then is going to be this 15 divided by x plus 3. That's the go trip. On the back trip, you have your time, which is going to be your distance, divided by the speed at which you went. So that's x minus 3. Now, here is the final tally here, is that in some cases, it will tell you about the distance. There might be information about the speed, but mainly it'll be information about the distance or time. In this case, they went on a 3-hour bike ride. So that means that the total time here was equal to 3 hours. So this is an expression of time, we'll call it T1. This is an expression of time, we'll call it T2. So what we can say is that the go time, the time 1, plus the back time, which is, we'll call it time 2, that's equal to the time total, right? The total time that they took to go on their bike ride. So we can set up our equation now. We can say that the total time, which is 3 hours, is equal to 15 over x plus 3 plus 15 over x minus 3. This is the time on the go trip. This is the time on the back trip. So added those together is their 3-hour bike ride. So we can solve this, and these are intended to be solved algebraically, but of course you can always do y1 equal y2 being the expression on the right side, and then find the intersection of the two just to help you to find the answer. However, algebraically is the intended way that I would like you to solve these. So let's see what we can do. We're going to get a common denominator here, which means that we're going to have to do 15x minus 3 over x plus 3, x minus 3. Again, notice that this is still t-go, time go. And then this other one is going to be our 15x plus 3 over x minus 3, x plus 3. And again, notice that this is still our time back, right? And that's equal to 3. So we can say then we can multiply everything by x plus 3, x minus 3 now, because we're saying really x cannot equal positive 3 or negative 3. And so we have 15x minus 3 in brackets plus 15x plus 3 equals, now we multiplied this, so these will cancel, this bottom will cancel, but it will be multiplied by this on the other side. So 3 times x plus 3, x minus 3. Now this is a quadratic equation that you can solve. All you need to do is expand. So we could say 15x minus 45 plus 15x plus 45 is equal to, and we know x plus 3 and x minus 3, that's going to be x squared minus 9. So we have our plus 45 minus 45. So you have 30x is equal to 3x squared minus 27. And now we can say, well, now we have, if we set everything to equal 0, we have 0 is equal to 3x squared minus 30x minus 27. And we can find out what this, use the quadratic formula, it might be able to be factored. Actually, it looks like 3 can go into everything here. So we can say 0 is equal to 3 times x squared minus 10x minus 9. And we'll be able to find this value. So you might find that when you solve this equation, that you might notice, yeah, there's 2 answers. One answer might not make sense. So you'll have to reason through why one of the answers might not make sense. Okay, so I'll leave some work for you to do here to solve for x, and use some reasoning to determine which answer is more appropriate. Okay, so let's take a look at our next question here. I'll leave this one for you to work on. Here's one of the things. If they stop half an hour for lunch. That's not included in the time that they are traveling. So you'll have to take off the half an hour that they spent at lunch. And let's take a look at question number 6. So we have question number 6 is, there's a typo here that we should probably take care of, and that is this one right here. So this one should say 21x. Now here's the idea. This was a question that was in last week's assignment, is that if this is the bottom and it simplifies to this, then that means that there was one of these factors, one of these brackets that was canceled out in the bottom and also gets canceled out in the top. So here's the idea. If we can factor 2x squared plus x minus 6, then we can find the factor that is not here anymore, and that is going to be the one that was canceled from the top. So let's factor this. We have 2x. I guess we can say this is times x, and it probably is 3 and 2, I guess. So let's see. We have 2 times 3. Let's see. Let's just turn this around here. I think this is going to be a 2 actually. So let me say if we did plus here and minus here, would that work? Let's see. 2x squared. If we multiply that out, and then 2x times 2 is 4x. 4x minus 3x is our positive x, and we have negative 3 times positive 2. Okay, yeah, this will work. Once we factored, we know that this 2x minus 3 is the factor that was canceled out of the bottom. Can you see that it's not here anymore? So that means it must have been multiplied by this to become the original top. So let's take this 2x minus 3 and multiply it by 5x minus 3. So we have 2x minus 3 times 5x minus 3. 2x times 5x is 10x squared. 2x times negative 3 is negative 6x. And then negative 3 times 5 is negative 15x. And you can see how this is the typo. This should have been minus 21x. And then negative 3 times negative 3 is positive 9. So can you see what the k value is in order for this to simplify? Now remember that x cannot equal 2 here. X can also, we're also going to have to solve 2x plus minus 3 also can't equal 0 as well. So 2x cannot equal 3, and x would not be able to be 3 over 2. Okay, we have one final question to look at, and that is the doing work together. Now this also a table will be very, very helpful here. So let's take a look at drawing a table here. We can say, all right, we have Callie working, we have Ben working, and then of course we have them together. So let's see if we can do that. A little messy with the drawing the table, but I guess you get the idea here. So let's see if we just had Callie working, that we can have her as this row. We could have just Ben working, and then we'll see what we have together here. Now it says that Callie can complete the shoveling by herself in 10 minutes. So that means that it would take 10 minutes for her to finish the shoveling all by herself. It would take 15 minutes for Ben to shovel all by himself. Well, let's see, how much time would it take Ben to in 1 minute, I guess. So if it took 10 minutes for Callie to do the shoveling, then really this is, in 1 minute, she can only do 1/10 of the job. And again, in the same way that Ben, if he took 15 minutes to do the whole job, in 1 minute, then that means he's only done 1/15 of the work. So this is the work done in 1 minute, right? So it's the fraction of the job that's done in 1 minute. This is the time that it takes. Okay, so let's take a look at what about in x minutes? So in some unknown number of minutes, we'll say that x, well, if Callie only does this fraction of work, 1/10 of the job in 1 minute, that means in x minutes, it's going to be x times 1/10. Or we could say that this is x over 10. Now, if we talked about Ben, if Ben can only do the job in 15 minutes, and that means in 1 minute, he only does 1/15 of the job, then that means in X number of minutes, then he's really done X times this 1/15 of a job, or we have X over 15. Now, what is this? This is the together is this unknown value of time that it took for them to do it together. So together, this is this unknown amount of time. Well, how much work would they have done? Well, we're going to have to put things together, but the whole thing then is going to be, this is like the amount of work that Callie has done. This is the amount of work that Ben has done. And so the equation that we're looking for then is that x plus x over 10, the amount that Callie's work, plus x over 15, the amount of Ben's work, is going to end up being the whole complete job, the complete task, right? So this is the equation that we're going to solve then. We're going to solve this equation. We have, and how do we do this? We're going to have to get a common denominator. So that's 10 times 15 is 150. So this is going to be x times 15. And then we have on this side, this is going to be x times 10 over 15 times 10. And then that's going to equal 1. Well, here we can solve this rational equation, right? We can say this is 15x plus 10x. And here, if we multiply everything, this is 150. Okay, so we have this is 15x plus 10x. This is going to be 25x. 25x is equal to 150. And now we can solve for x. You can see that x divided by 25, divided by 25, 150 divided by 25. And remember that x represented the time it took for both of them to complete the task together. If we see this x equaling 150 divided by 25, think of 25 as like quarters. So $1.50 has how many quarters in it? And So x is equal to 6. So when we see this, when x is equal to 6, it means that together, when they work together, it's going to take six minutes. So does that make sense to you? Well, Callie can do it in 10 minutes by herself. With Ben's help, it's going to be less time than her doing it by herself. So um, this 6 minutes makes quite a bit of sense for us. Okay, that is your assignment. Hopefully you are working hard. Continue to work hard and do well. Please let me know if you have any questions, and good luck on your assignment and in your work.